Okay, friends. So this video actually, I'm just showing you how I use R for analysis of variance and making box plot, doing some descriptive things, and then doing the ANNOVA. And actually, I'm showing what I'm doing my way, my way how it is. So of course there will be different other ways, but yeah. So this is actually the dummy data, same kind of data I used in my previous videos, where actually it's a bit different. That this time I had the experiment for the multi-location, but here imagine I have different nitrogen doses I have used. So like in wheat, you can use different doses of nitrogen, and then I have a replicated in RCBD design. So I arrange the data like this, and then I have set of varieties and which are grouped according to whether they are exotic lines, they are local lines, they are checks. Yeah, so I have done that, and then I have the severity data, the host reaction, 1,000 grain weight, biological yield, grain yield, and harvest index. So my question is actually whether any of these parameter, or I will check one by one all of them, they are actually there's any significant variation among the varieties or due to nitrogen dose. So the first thing is to arrange the data like this. So like for each variety, at a given in a given replication at a given nitrogen dose, I have a scoring for rust, I have a scoring or a data for 1,000 weight. So I arrange it in this way. So the easiest is to arrange, like for each variety you put the data in a given replication, then for the second replication and all of them in the same nitrogen dose, and you can then go to the second nitrogen dose and third nitrogen dose, so you can arrange it accordingly. Yeah, so what we are then doing actually, the first thing to do is to make this data in a way that it could be read by X by R. So there are different way you can say ways, but to me the easiest is I just copy it and I just paste into the notepad. So I just paste it to the notepad and I save this file as txt. So I have made a folder for this purpose for this video. So I will just go and save it in that folder, right? And I will name it something like, okay, data test, right? And .txt. So it's a tab delimited file in txt format. So I have that file now. I can see it here, right? And now I will go to R, where I will show how I use it in R. Okay, so this is what we have actually in the R studio. So that's the console of our studio. You can see it here. So there you have actually this script which you can edit, you can work, and this is actually in the bottom is the console where you see what's going on, actually the command area, and then you have actually this area to the right top where the different objects which are created are there. And of course then you have this lower right panel where actually you can have the plots, and you can also have information about packages, etc. You can upload packages, etc. The idea for the beginners, actually for my students, is very easy in our studio. You can put the scripts and you can put actually the explanation. If you put a hashtag in the start, what comes after that till the enter, it will not be considered. Actually, it will not be considered as command. So like I put, okay, this script is for Boxplot and ANNOVA, and then I have to load the file. What it has to do is actually, so next you have the command. The beautiful thing is it's putting this green for the comments, and the main command is there. So I'm creating an data frame, an object test data. What it is actually, it is based on reading a table of this data test.txt. So it's actually the file I made in notepad. You can just save as excel in tabulated form. So it's a table, yeah, it will take it. And then I have the header, which means that on the top I have I have actually the labels, right, the headers. And then if there's some missing data, you can tell it how the missing data is actually labeled. So underscore, it could be -9 in some of these population genetics things. You can do that. I prefer underscore. In this particular data, I haven't used, but doing that, actually, the first thing is you have to ensure that the R where you are working, it is considering where your this file data test.txt is. What I do is it's not always easy for many people. They prefer to have one big file and then do analysis. But for the beginners, I put my R script in the same folder where I have the data. So what I do is then I will click session, set working directory to the source file. So here it is showing that it is putting it to the working file, right? The working directory. So now to run this command, there are different way. You select this and then you can do run. Okay. Alternative is also that you just control enter. Yeah. So then you will have a habit to do control enter. Now in the console you can see what it has done. So there it is saying that it has read it. There's no comment, so it means the file is okay. Then for example, I have a parameter like yr severity, and now when I click yr severity, it doesn't understand. Sorry, my laptop is in Chinese. It's saying it doesn't understand the yr severity. No, there is this yr severity data, but it's not considering it. So actually what I have to do is to attach the data. So now it has this test data attach. And for example, if I now click on YR severity, it's giving me the values of YR severity. So it understands now what it's YR severity, or for example, I have put grain yield, right? So now it will understand what is grain yield, you see. So yeah, so you have to attach this uh, data set you have created. I also prefer to have the summary on it. So the summary is good because for example, it's giving you this information that what you have about different parameters, like okay, it's telling you the genotype is actually is categorization parameter. Nitrogen dose is the same, replicant is the same. It's not actually numerical data. And severity is a numerical data, so it's giving you the minimum, maximum, and the quartiles. The look again, the host reaction is actually a qualitative data. It's telling you it's a qualitative data. 1,000 weight, you have the minimum, maximum. So this is good to have this if you have some bugs in the data. Instead of decimal, you put some comma or something, or you have a problem in the it. So you can see it here. And in some cases, for the students and for descriptive statistic, you have the minimum, maximum quartiles data. You can just copy it and work in Excel or Word as you prefer. Another thing I just use just for my own self is the header, the first row. And why I do it, I will show you later why I'm doing it, but it's very much useful. So what I do is actually I copy this line, okay, and with this hashtag I put it here, right? So actually here I have the name, the short names for my different parameters and factors, and later on I'm using it in my command. So then it's good to have them here, right? Okay, now to see the normality of variable, you know that actually your application of an OS based where your data is normal. At least you have to look at it how it looks. So this is what I have, right? This is how my data is. So you can see that this is not completely normal, but okay, this you don't have a lot of skewness in it itself. So this is what you have. Actually, you can go for some transformation, but I'm not going. This is not the topic of this video, so I will just go further for the analysis. But you can see this qqnorm plot where you have the information whether your data is having a big skewness or big non-normality, or it so gets normal. So then you can go for further analysis. The next step is to go for the box plot. So what I do is actually I'm telling it that create the box plot based on the test data, where you take the YR severity and the function of nitrogen dose, and then you can label it if you like. You can do without the label as well, but I have done like on X it will be nitrogen doses, and then you have the YR severity. So when I click, I have this beautiful box plot, and you can zoom here actually to see how it is looking. But yeah, so what you have different response to nitrogen doses. Once again, it's the data just for understanding, it's not the real data. So you can see that there is some variability, but across different doses, but not a lot. For example, if you want to have another box plot for the genotypes, right? So then you say box plot test data wire severity in the first function of genotype, which I have put as gin, right? And then it's nitrogen dose, you just put genotype. And of course, I have many, so it will not be very visible, but still you can see. So here you really see the differences among the genotypes, how they behave, right? How do they behave for different varieties? If you recall, in the start, I have said that I have also different set of genotypes. So for example, I'm interested in the set of the genotypes, and this line I have said is helping me very much. So it's G.Set is actually the germplasm set. So G.Set. The only thing with R is that you have to use the same same comma or dot how you used earlier, and actually the upper or lower case is sensitive, the case sensitive. So yeah, you have to take care. Now I'm just want to see the box plot for the germplasm set. Okay, and now we will see how it is. So you have actually the yellow severity for different germplasm set. Yeah, so you can see that in local lines you have more severity compared to the, yeah. So you have more severity compared to the exotic lines and the checks. The local lines have more severity. So this is actually Boxplot is informative. To save it, you can just click on export. You can save as PDF. You can save as image, and you can actually directly copy as well. So it's better that you save it in as PDF or as image, and try to save it in a good quality, because later on you can then you can, for publication etc, it's good to have a good copy, otherwise you have to generate it again. Okay, this was about the box plots. Now I want to do the analysis of variance, and this most of my agriculture students are doing it. So here the important thing is actually that you have to know about the model you're using. So what I'm doing, I'm creating a result object. It's based actually a linear model where the YR severity is actually a function of replication plus nitrogen dose plus genotype plus their interaction. Another way to do is actually directly just try replication plus nitrogen dose into genotype. But yeah, you can do it this way. So because I have used RCBD, so I'm expecting there is some blocking effect of the replication. So I would like to see that. And then also the nitrogen dose and genotype. So I'm just control enter. It has created this result res object. And now I would like to see the analysis of variance. So here is my analysis of variance. I will just put it a bit up there so that you can see it clearly. You can see that this blocking effect of the replication is non-significant, and the nitrogen dose is there, it's significant, highly significant, and then the genotypic effect is also highly significant, and the interaction is actually non-significant. So yeah, this is actually giving you that information about the analysis of variance. I'm not going to explain all of this. My aim here is just to let my students to do analysis of variance and box plots with R. And then you can also generate the summary on the data where actually you have like the multiple R square value, F statistics, adjusted square. Yeah, so you can do it. You have all of these information, right? So the idea here is that you generate ANNOVA table and you generate the box plots on your parameters. What I have done is for one parameter, which is YR severity, right? If, for example, I'm interested to do it for another parameter, right? So what I have to do is just change this parameter. So like instead of YR severity, I would like to see the grain yield. Okay, GY was my grain yield. You can just go up as I did earlier. You can see this 1000 weight, biological yield, grain yield, and harvest index. So I'm now going to do it for the grain yield here. Okay, and I will see what is giving me. and then ANNOVA. So here you can see that actually the replication are also, there is a cross replication variation which is significant. The nitrogen dose effect is significant but not very highly significant. And then you have it, so it's actually at 10%, you can see. And then you have the sorry, 90%, yeah. And then have you have the how to say, the um, genotypic effect is very highly significant, and the interaction is also once again not significant. So you can do it for different parameters. The same thing, you can create the box plot for another parameter. Just you can change the severity into grain yield, okay. And you can, for example, in this one is for the germplasm set, if I do it, okay, and you can just click, so you have the grain yield. Of course you have to change this wire severity, you change it to grain yield, okay, grain yield. And you can, if you like, sometime kg per hectare or whatever you like, whatever you want to write, you just write it in this here, and you will have it. So the grain yield is there, and you can see the check says the highest grain yield, the exotic line the lower, and the local line further lower. So this is just generating box plot in R and doing analysis of variance in R. The source code I will just paste in the bottom in the comment section of, or the description section of my how to say, video, where you can just copy and then you can write to me and I can help you doing analysis of your parameters. So it's just about the doing it. Once again, I'm saying I'm presenting what and how I'm doing it. I know there will be better ways. The computer people will be even better. The biometrical people will be making it even more easy and more attractive. But this is the way I'm doing, and I would like to share it with my students so they work on it, they modify it, they improve it, and then they work on it and really come up with good analysis and results. So thank you for watching, and wait for another exciting video, and do tell me what should I improve in such clips and videos.